Assume Gedanken conditions exist in this example. A stationary observer on Earth sees a very fast car travelling by at 2.5 times 10 to the 8 meters per second. When stationary, the car is 3 meters long. Calculate the length of the car as seen by the observer. So if you're in the same frame of reference as the car, in fact, if you are driving the car, you would measure its length as 3 meters long. Okay, that proper length doesn't change. Regardless of whether the car is stationary or moving, if you are in the same frame of reference, you will measure the same distance. So, L0 is going to be 3 meters. Okay, so if we're in the same frame of reference as the car, we're going to measure its length as 3 meters. So now we need to work out our Lorentz factor. So 1 over square root of 1 minus v squared on c squared, which is going to be 1 over square root of 1 minus, now remember if they're both 10 to the 8 we don't need to put those in, 2.5 squared over 3 squared. Okay. All right, I get a Lorentz factor of 1.8. And I think that's what we got yesterday when we did a similar example at the same speed. So, a Lorentz factor of 1.8. So therefore, the length measured by an outside observer is L0 over our Lorentz factor. So L0 will be 3 over 1.8, which is 1.67. So if you are looking, if a car is going past you, if our very fast car is going past you, its actual length is 3 meters, but it's traveling at a really close, or pretty close to the speed of light, you would see that car, its length will have contracted, to your point of view, to 1.67 meters. Okay, so it started at 3, but it's contracted to 1.67. Now it's important to remember that the person in the car doesn't feel like the length is contracted at all. They would see your length contract. Question?
Just a question. With contraction and then dilation, what's the point? Why do we need that? Because, okay, the car's 3 meters. To us it looks like 1.67, but in actual fact it hasn't changed from 3 meters long.
No, but it has.
But that's what we observed, but as a...
But what is reality but observation? The car is both 1.67 meters long and 3 meters long at the same time.
But how does that help us? How does that help people?
Fair question. I'm going to give you some pretty specific examples after this as to where it is really relevant.
Yeah.
Okay? But for now, I want you to have a go at the next one.